For example 5, then it just wants us to pick how we want to approach this. Well, the first thing is I want to make sure that my equations are in the same form. The easiest way, or the most consistent way that I do this, is saying that I always want my constant on the right-hand side and my variables on the left. So I'm going to say the first equation is going to be 4x plus 2y is equal to 13. I'm going to say my second equation is going to be 3x minus 5y is equal to 26. Now I can choose which one do I want to make match. Do I want to make my x's match or do I want to make my y's match? And honestly, the answer is it doesn't matter. So in this case, I'm going to make my x's match to cancel them out. And I'm going to say that I need to multiply all of the first equation by 3 and all of the second equation by 4 so that my x's match. So what I really have is my equation 1 is going to be 12x plus 6y is equal to 39. My equation 2 is going to be 12x minus 20y is going to equal 104. Now what I'm going to do is I'm going to eliminate the x's by subtracting. So the x's are gone. 6y minus negative 20 is going to be the same as 6y plus 20 or 26y. And if I want to take 39 minus 104, I'm going to get negative 65. Which means that y is going to equal negative 65 over 26. Now, if I can reduce this properly, I can say that 65 over 26, because they can both be divided by 13, is just going to give me 5 over 2. I'm going to choose, in this case, to substitute it into equation 2 because x is already by itself in equation 2. I'm going to say that I'm going to go to equation 2, and 3x is equal to 5 times negative 5 over 2 plus 26, which means that 3x is going to equal negative 25 over 2 plus, well, I want to put the 26 over 2 so that I can combine these fractions and say that this is going to be 52 over 2. So 3x is going to equal 27 over 2. And then divide both sides by 3. X is equal to 9 over 2. So my solution in this case is going to be 9 over 2 and negative 5 over 2. If you wrote it as decimals, it's 4.5 and negative 2.5. But remember that we typically prefer the fraction form. And we can verify this on our calculator to make sure that it works graphically. All right, when we get to example 6, well, we don't like fractions, typically. So the first thing we want to do, just like what we would have done in our general form in the last unit, is we want to get rid of fractions by multiplying by the lowest common denominator. So what I'm going to do is I'm going to multiply all the terms in here. If I have 3 and 5, I'm going to multiply all the terms by 15. So I'm going to take 15, I'm going to do this by 15, and I'm going to do the 2 by 15. I can divide out the coefficient and the denominator and say that this would be the same as 15 divided by 3 is going to be 5 x minus 2's. Minus 15 divided by 5 is going to be 3y plus 2's, and that's going to equal 30. Or 5x minus 10 minus 3y minus 6 is equal to 30. 5x minus 3y is going to equal 46. In the second case, the common denominator is going to be 10. So I can multiply all of these by 10 and then divide it out. I'm going to say that I'm going to have 30 over 5 x plus 1 minus 40 over 5 y minus 3 is equal to 210 over 2, or 6 x plus 1 minus 8 y minus 3 is equal to 105. 6x plus 6 minus 8y plus 24 is equal to 105. And then I can say that 6x minus 8y is equal to, well, the 6 and 24 is going to be 30. Take that away from the 105. 75. Now, I can see that I've simplified them, but my coefficients of my variables don't match. So I'm just going to pick one of them to try and make them match. And in this case, I'm going to say that I'm going to make my x's match. Well, the lowest common multiple between 5 and 6 is going to be 30. So I'm going to multiply all of the first equation by 6 and multiply all the second equation by 5. And I'm going to state for the first equation I have 30x minus 18y is equal to 276. In my second equation, I'm going to have 30x minus 40y is equal to 375. And to eliminate, I'm going to subtract them from each other. The x's are going to cancel out, and if I have negative 18 minus negative 40, I'm going to have 22 y's. And 276 minus 375 is going to give me negative 99. Y is going to equal negative 99 over 22, or I can divide the top and the bottom by 11 and say negative 9 over 2. Now, if I know that is negative 9 over 2, I'm going to substitute it back into one of the equations. Doesn't really matter which one in this case. So I'm going to try and solve for my x. Now, in this case, I'm actually going to use, typically I don't like to, but I'm going to use one of my simplified equations and then just verify the solutions in the calculator. So I'm going to take my simplified version of this and say that if I have 5x minus 3 times negative 9 over 2 equals 46, then 5x is going to equal, 5x plus 27 over 2 is equal to 46. 5x is going to equal, I need to put 46 over 2, so it's going to wind up being 92 over 2 minus 27 over 2, which is going to give me 65 over 2. And if 5x equals 65 over 2, and I divide both sides by 5, just divide the numerator, and x is going to equal 13 over 2. So my solution for this is going to be 13 over 2 and negative 9 over 2. And there's my answer.